Hello students, this is lesson U6A06b. By the end of the lesson, you should be able to say I can solve for lengths of chords, secants, and tangents. So here are the concepts that you will need for this exercise, for this lesson. If you notice in the previous lesson, I've introduced all of these concepts to you guys. However, we only really applied these two concepts here, which involve the relationship between secants and tangents, or tangent to tangent. What we are going to focus on in this lesson will be these two concepts here, which is the relationship between the lengths of chords and secants. And a way to remember this is, and I've said this in the previous video, but I want to repeat myself here. The way to remember this is not to memorize the equation verbatim, but instead try to have the diagram accompanying it. Okay, try to understand what the equation is saying so that you can have an overall understanding of the big picture here. So what this is saying is, if I take one chord that's been partitioned, take the partition and multiply them together, it will equal to the product of the second chord, the product of the partitions of the second chord. If I look at the secant to secant length relationship, same thing could be said, okay? So in this equation here, it's saying that the portion that's outside multiplied by the overall length of the secant line will equal to the portion that's outside multiplied by the overall length of the secant line. And this is the way that which we are going to approach memorizing this. I hope that you are not memorizing the equation verbatim. Once again, that you are trying to understand this with the diagram in mind. Let's take a look at our first problem here. So what I have, pause the video to see if you can figure this out on your own, and then we'll regroup. The goal is to find out what is the length of ED, being that we have two chords intersecting. Hopefully you guys had some time to think about this. So the length of BE is 4. The length of EC is 6. The length of AE is 5. And we're asked to find out what is the length of ED, which I'm going to call this length here X. So what we recall from the previous slide, we're going to take the partitions of one chord and multiply them together. And that should equal to the product of the partitions of the second chord, which is 5 times 6. By isolating x, I'm going to end up with 30 over 4, or x is simply 15 halves. And that is the length of ED. It's 15 halves. Let's take a look at the second problem. Pause the video to see if you can figure this out. What I have now is two secant lines intersecting. So I have the length of AB, which is 8. And then I have the length of BC, which is 2. And then I have the length of CD, which is 3. And I'm trying to find out what is the length of ED. So the length of ED, which I don't know, okay? However, the formula, okay, calls for the product of the segment that's outside multiplied by the overall, right? So I'm actually going to call the overall length here, I'm going to call that overall, I'm going to call that X. So what I'm going to do is I'm going to figure out what is X first, and then from there I can then figure out what is the length of ED. So let's do that. So if I know that 8 times 2 times 2 plus 8, then that should equal to 3 times the overall length X. If I do this, I'll end up with 2 times 10, which is 20, is equal to 3 times X. And then I can divide both sides by 3. So therefore, X is equal to 20 thirds. However, 20 thirds is not the length that I'm looking for. I'm looking for the length of ED. The length of ED will be 20 thirds minus 3. So what is 20 thirds minus 3? 20 thirds minus 3 is 11 thirds, because 3 is 9 over 3, so 20 minus 9 is 11. Let's take a look at the last problem here. Actually, this is not the last problem. I take that back. So, pause the video to see if you can figure this out. The length of AC is equal to 7, so the overall length is equal to 7. The length of ED, which is again the overall length of the second chord, is equal to 8. The length of BD is equal to 2. If the length of BD is equal to 2, then therefore EB must equal to 6. I know the overall length of AC is equal to 7, and we're told that if AB is greater than BC, find the length of AB and BC. So I don't know either one of them. However, if I call AB, let's say we call AB X. Okay? If AB was X, then BC would have to be 7 minus X, because I know the overall length is 7. And if AB was X, all I have to do is just subtract from 7. So according to the theorem involving the lengths of chords, the partitions, the products of the partitions should equal to one another. So if I take 2 times 6, it should equal to X times 7 minus X. And this turns into yet another algebra problem. So 2 times 6 is 12. The right-hand side will end up with 7x minus x squared. I'm going to bring everything over to one side because this turns into a quadratic equation. I end up with x squared minus 7x plus 12 is equal to 0. From here, I'm going to factor. Are there two numbers that multiply to positive 12 but add to negative 7? As a matter of fact, there is. And the two numbers are negative 4 and negative 3. So what are the two numbers then? It's going to be 4 or 3. Now, which is it though? Okay, so we know that AB has to be greater than BC. So if that's the case, if X is 4, then that means AB is equal to 4, and BC therefore has to equal to 3. Right? AB can't be 3 because if AB was 3, BC would end up being 4, and we have to satisfy this condition here. So therefore, AB is equal to 4 and BC is equal to 3. Oh, this was the last problem. Okay.